Hello, engineers. Welcome to SystemDesign.us YouTube channel, where we conduct distributed system design mock interviews. Our interviewers are senior FANG engineers, and we also have a course at SystemDesign.us. Please listen the entire interview and visit SystemDesign.us for feedback to understand what went right and wrong. We also suggest actionable solutions to get better at designing systems. And don't forget to subscribe to our YouTube channel and click that bell icon so that you do not miss any new interviews.
Okay, cool. Let me put up my question. I mean, you got that question there, but I kind of wanted to make additions to it, if you don't mind. But we can start with that. Let me post it there. So do you see it in the plain text?
Yes.
Okay, so and there's a whiteboard on Zoom, so you can use that
Okay.
to design
Yeah.
your solution. So yeah, whenever you're ready, take your time to think through the solution.
Okay. So Mint.com is a free web-based personal financial management service that allow its users to integrate with financial accounts to automatically extract their data. Okay, it's like we have to link our financial accounts and manage their personal budget. Okay,
That's right.
Okay.
Yeah, take your time, however many minutes you need, and think through it, and come up with a good solution.
For me, it's like I have never given any system design interview yet, and I have to appear for a big company next week for Amazon.
Okay.
So I don't know, like, how should I start? Like, so
I think my best advice in this regard is just do what you would actually do when you're actually designing a system in your office. You know how you would think through those problems, and how you would come up with the solution. So you have to anticipate it, the design, the problems, and you know how you would fix those problems. Essentially, those three things are really important.
Okay. So I haven't used Mint, but
I mean, I haven't used either, but you can just assume some financial management service.
So to manage their personal budget, right? So
That's right.
So the obvious feature, the first feature will be linking their personal accounts, right?
That's right.
So by looking at the definition, like, the manage their personal budget is like the user has to provide, like, what is their limit each month or any each week or something.
You can keep it open, right? I mean, no one really analyzes their financial budgets every week, right?
Okay. So the Mint platform should show how much the person is spending each month, and where it is spending, like, show the usage in pie chart or something.
Yeah.
Also, like, category usage, right?
That's right.
And so it's a web-based, like, website, not the mobile application.
Yes.
Okay. And it should like, if there isn't, like, limit set by the customer or the user, like, it should show any alerts based on the spending, like if the monthly usage gone above this limit, then it should show an alert or something.
Yeah, makes sense. So just to be clear, I'm looking for like a full end-to-end solution
Okay.
of how you would build this web-based entirety from the website to the backend to the storage.
Okay. Okay. What are the features? What else is the features of this apart from just showing the pie charts and all, like giving alerts and notifications? Does the user has to enter something manually, or just the task is to just link the their bank accounts and over and just look at or like we are entering the limit from the like user side, so apart from entering the limit, like what else the user can do like on this platform?
So you're talking about the add-on right now, right?
Yeah.
So we can leave that for later once you're done building this system.
Okay.
But some examples of that could be, like suggesting credit cards or suggesting, other financial services, like wherever the user can, manage their finances better, or they can suggest, hey, you're spending too much on this one category, and how you can reduce that particular category, stuff like that.
Okay, so these are the basic feature that needs to that must have, right?
Let's start with those.
Okay, so once I gather functional requirements, like I have to gather the non-functional requirements, like how many users are. So
I can give you one overview on how this works in large companies, because this is a good systematic approach where we go through functional features and non-functional requirements. But when building a system, when building a large system in a large company, or when you're scaling it out to many millions or hundreds of millions of people, you don't really know how many people are going to be using it. So it's kind of hard to give these non-functional requirements. So the ideal design, what the ideal design does is it linearly scales with
so we
as more users join the platform. It generally linearly scales as you add more server power or machines.
So we had to basically start from like the monolith service, like single service server service, where the customer
we don't have to start with monolith, right? You can split the services. I mean, that's the whole magic of system design, right? Where you need to be able to anticipate which features will be isolated in which service, so that they scale better, and then
Okay. Yeah. So so we'll just skip this, like how many millions of users are going to use this. Like we'll start like what will be the high level design, right?
Yes. That sounds good.
Like how have like the big companies, like do they expect non-functional requirements right away if they once they give the problem statement after we discuss these functional features?
So to be honest, when you think through, when you actually solve these problems, in these large companies, if it is a feature that you are building on top of an existing product, then you kind of have a good idea of these non-functional requirements, right? Because there are existing number of users that are already using the product, and you kind of know the trends, which features they're using the most, how many people are using it per day, per month, stuff like that. And you also know individual, let's say, amount of data that is flowing through the system, or the amount of messages that are getting flowing through the system, or the amount of storage you need. So all of that is pre-known if it is an existing product that is already built and you're just adding a feature on top of it. But even at a large company, if they're building a product from scratch, you don't know it. You just don't know it.
Okay.
So you cannot discuss it because you just don't know it.
Okay.
Yeah. And
So
since we're building it from scratch,
yeah.
what you would have to do is you would have to go from features. So how you would actually just provide these features as if you're providing it for a few users, but then make sure that it also scales as large number of people join in, because that's what happens in large companies, because
Yes.
once they release something, immediately a flood of users come in,
Yeah.
right? Which is not the case in startups where their users kind of slowly build up over time.
Okay. Okay.
So
So
for you, I would start with this. Think through these features that you want to put in, and go to the whiteboard and
yeah.
start putting in boxes where you
Yeah.
think those features should sit, and which other services they should interact with, where do the users sit, where does the storage sit, and all that.
Okay. So uh, so the first thing we will require is uh, a service which can uh, the service which will link your bank account with the Mint, right?
Yeah.
It can start as a linking service where so the banks like which like is that kind of like auth stuff, right? Where we have to log in onto that platform,
Right.
and then once we log in, like we can fetch their data, right? And
Right.
that it will be like a API from those banks, right? So the Mint will consume, right?
Yes. Yes. So
Okay.
essentially, any user can plug in any of their bank accounts
Yes.
through whatever, through their online login information, or
Yeah.
these days they have these APIs and all.
So the
So
Mint will provide like which kind of bank or what all those are banks it supports, right?
yeah,
Yeah. So the each banks like will have their what did say the APIs which the Mint should consume. Like so the linking
that's
service
right.
handle that
Yeah,
part, like
yeah,
consuming the bank's APIs, right? And fetch financial or the transaction, right?
yeah,
Fetch financial transaction, and it will, once it fetch, it will store uh, and store this on platform, like Mint platform, like in DB or something.
sure.
Okay, so we have a linking service, and once it pull all the transactions,
Hmm.
so the transaction like is it like per month or it's like we don't need to worry about, like it's like uh, it pull all the records, right? All the financial records, like since we started this credit card or is
Right.
okay. It pull all the history since the beginning.
Yeah.
Okay.
That, and plus it depends on what the bank supports, and
Yeah. Yeah.
so it'll be slightly more complicated. Yeah.
Okay. So like we will just consider like it will pull all the history since the beginning, and it
Sure.
generates all the
Sure. We can assume that.
okay, and store this on the platform. And how what so this is one service, and another service is like to show the usage in terms of pie charts. Like we need some uh, uh, like uh, like key generations, like not key generation, the analytic service where it uh, generates, or it reads your data from the DB, and it so also the UI needs to show up like per credit card basis, or it should be like combined stuff from all the accounts, like how much you spent.
So now that's an open-ended question,
Okay.
right?
Okay.
What do you think might be better? Because
yes,
the way it would work in an interview is the interviewer is not going to give you, at least what's your experience level, by the way?
I have 4 years of experience, but like I don't have like much experience in designing myself, because we have like
Sure.
a separate architectural team.
Yeah.
I did not get that chance to design by myself.
Exposure.
Yeah,
Right.
exposure.
Yeah. I think so at a very high level, how it works is they don't give you anything.
Okay.
That's just the reality.
So we have to like ask questions and get clarification, right?
Clarification, or sometimes you just have to make decisions and correct them later, or you just have to make, most of the times you just have to make right decisions.
Okay. So let's assume that like we will store all this information in separate like for each bank we'll store it separately, and we will have combined as well as the separate charts for each of the account the customer has linked.
And who will do this combination and storage, and which format would it be stored?
Yeah, so so the storage part, what we will have to do is like I think we will have to store it in the SQL DB, where I'm thinking of SQL because it has a schema, and
right.
Yeah, so we can gather the transactions, right? We can gather the transactions, and we store it into the DB, like the user ID or the let's say, I think we can store
structured data, basically.
Yeah, structured data. User ID or so the transaction in one table, let's say transaction ID, and transaction amount, bank name, transaction date, so if we store this information, we can calculate the amount per let's say we can as we have bank name, we can calculate the amount per account per month, because we have transaction date, and so we can have the indexes and get on the bank name, because if we have to generate the per bank per account, right? And so the total amount we will get by the date, we have date, and the current cycle of the month, or whatever the user select, the range. So from the transaction date, we can get the transaction amount, and these are the just transaction IDs for those amount. And so this will be the schema for the DB to store the transactions in on our side once we fetch it. And so the analytics service, we'll name it analytics service, which will gather the data from this table and generate do some calculated like based on the user's input or the predefined inputs like per month or like per quarter, and display the chart for the user.
So this analytics service will read all the tables and crunch all the data and then display it?
Yeah.
Okay.
So yes, it will calculate all the data like for the user, for the given user. It will fetch it once user logged in, like we once a user log in it and the user wants to select their usage, it will gather the data. And so every time the user has to run the query when they want to see the chart. So instead of that, like do the calculation, and like we have to store this data somewhere, like in separate DB, like per bank per month, so that it doesn't query this big table every time, right? And
sure. But then wouldn't this service wait for a long time? How is this service running? Is it running as a REST service, or
so
how is it crunching data is what I'm asking? Because it would have to, let's say, generally people, let's say on average have 5-6 accounts, and if you're pulling data from all these banks, it's going to take a long time for it to fetch all the data and then crunch all the data and aggregate and generate the charts.
What we can do is like this will be the standalone service in which is running in the backend. Once the user links the account, the analytical service in the backend will do this stuff like once every day, or because the value gets updated, right? So this will be running in the backend, not get called by the user APIs. This will be like getting data from DB and calculate the analytics and storing in the separate DB or cache servers, so separate DB. Okay. And the DB will store the.
So, but then now, if it is stored in a separate database, then now you have to carry so many, like each of these service, at least the analytics service will have to carry so many different credentials, right? To connect to all these different databases and keep those connections open to all. So let's say, I mean, there are like hundreds or even thousands of banks, probably tens of thousands of banks in the US.
Yeah.
So in that case, each service instance will be.
I mean, like it doesn't have to be keep the connection open, but like it can pull the API once a day, like or it can pull from the banks like once a day or twice a day from the banks. Like, does it have to appear immediately on the Mint whenever we do transaction on our from our credit card?
Probably not.
Okay, so So this we can do like once or twice a day. In that way, we can we don't.
No,
have,
I think yeah, that part I understand where we are fetching from all these banks separately,
yes.
but I'm questioning why do they need to be stored in different databases? So if you're storing from each bank, you're storing that data in a different database, then on your own inside your own system, you have to maintain these connection credentials to the database itself, right? Not to the bank database, but to your own database where you will be storing all this data.
So do we have to show the transaction, each transaction to the user? If we don't want to show the transaction to the user, we don't need to store all this transaction here. So I was thinking like we can show the transaction to the user instead of just like rather than showing pie charts, like along with the showing pie charts. Uh, if we don't want to show transaction to the user, then we should discard this transaction like a table, and we only should combine the data. Like this analytic service, we get the uh, values from the banks and uh, process it on the server and store the accumulated result into the DB instead of like storing all the transactions.
Okay. So I think I misunderstood when you said you will be storing it in different databases. I think what you're saying is you will pull, or I think keeping the transaction and transaction ID and all of that is fine,
Yeah.
because even while displaying, you can omit that information. But I was confused whether you were saying that while pulling the data from the banks, you would store it in different databases or in one single database is what I was confused by. But it sounds like you're saying that you would store it in a single database.
Yeah. So I will store
Okay.
it in
Yeah.
single database. Like that's why I
Makes sense.
mentioned user ID
Yeah.
and the
Yeah.
bank name. Uh, and so each user, so for all the user, like data will be in the single table, and based on the user ID and then bank name, we can just generate
Sure.
the and generate the data for that current user, right? So we
Sure.
don't need
Sure.
a separate table for a separate user.
Sure.
Yeah. And the analytics service, like it will run twice a day or once a day to fetch the uh, uh, fetch the data from the banks and uh, get the data and insert into the DB. If those transactions are not fetched before, it will only get the new transactions and add into DB, and it once it's stored into the Mint DB, then it will run the analytical. It will run the calculation on those transactions, and it will like show accumulated result per account or some uh, per user ID.
Sure. So this analytics service, who will kick off this analytics service? Who will let
So
this analytics service?
we can schedule, we can run this schedulers on this like once twice a day. It should pull all the records, like not all the records, the latest records from the bank. We can schedule a cron right on this analytical service. It will
Sure.
in the back end, it will do this job, and user don't have to wait every time. Like every time it logins, it doesn't have to wait and for this Mint service to pull the latest records from the bank, right?
Sure.
And it will take a lot of time to again pull it, again calculate it, and just display it to the user.
Sure.
Yeah. So the another DB will be like because the analytical service has to process all those records and generate some data. So the generate some data, like what kind of data we want to show. We want to show the user the total amount they spent this month per account, uh, or the based on the date range we want to show them, right?
Sure.
So if they want the date range, do you want to support that feature? Because if we want to show them using the date range, then
I think
we
that's fine. I think that's more of a detail on.
okay.
I would rather get the broader pieces
Okay.
into the design. So what else do you think is
Okay.
needed?
Yeah. So the we will need application server where we can so we can define an API where whenever the customer logins, it calls the server and get the latest data and display it to the user. Right, the application server handles getting the request, and it looks into the DB, accumulated DB, what are the accumulated data we have stored for the banks. So we, like, before developing application server, can we like define an API, like what kind of API we want, and then based on those parameters we can get the values from the DB and pass it to the UI to display as, right?
Sure.
Get, it's like, so what the user
I think it's API is fine.
Okay.
I think API is generally not very useful unless you're really exposing it to external users.
Okay.
So definition of APIs are not very useful.
Okay. So the application servers are responsible for getting accumulated data from DB, from accumulated DB, and passing it to the UI, to the user instead of user. And the user, I mean like the client, the web, once we have to just send the data to the client, and the UI will take care of like how it needs to be presented. So this these are the three parameter, like basic parameter I can think of, and the DB, like obviously the DB. So the user flow will be like, so do I have to like handle the creation of the user and like
user account?
Yeah, no, user accounts.
I think you can skip that part.
Sorry?
I think you can skip that part.
Okay.
You can assume that most users have accounts already.
Okay. So once the user has account, let's define the linking service. And so I had to like I had to show the banks right here, banks, which exposes the APIs, all bank services, which exposes the APIs, and this link service is connected to it. And whenever the user, so we will have a set of load balancer here. Let me load balancer. We will have application servers, means and this application will application server will route the request to the linking service.
Sure.
Yeah. And what else we have is analytical service, right? It will be running in the background. So we will have it here. Let me try it here. and it will gather data from the databases. So once the link service gets the data, it will store into the DB. So the DB will store it here. DB. And this links service will store the value into the DB. Select. Okay, keep it here. And this analytical service will read the values from the DB per user and generate the analytics and store the results in the analytics DB.
I think this makes sense. Where do you think, I mean, in the interest of, running, now that we're running out of time, I want you to go through, like, where could you see like bottlenecks or, like high traffic problems, or where would they occur and how would you solve them?
So, and it will pass this here, and once the application server gets a request,
so when you say accounts DB and analytics DB, is that like different databases or what is it?
It's like a different databases. Like this has the per transaction records for the user, right? And this analytical service
database as in different tables or different databases, instances.
We can store in different databases as well, or the tables is like I mean like a different database instances to only keep the records of the accumulated results, right? Analytical, like what analytical service do is like get the each transaction per user per bank, like
right. But then now if there are two different instances, you can't really have SQL constraints and all of the SQL features, right?
Yeah.
If they're indifferent, so how would you solve that problem? Because if they're living in different instances, you cannot have foreign keys, you cannot have like constraints within different tables. So all of that will have to be managed on your own.
What I mean, like here, so this will be the accounts DB on this like accounts DB, and this will be the analytics, which will be separate DB, will have separate row for like per user ID. User ID we will show the total amount total amount for range base, like
no, I understand what you're trying to do. Yeah. I'm just trying to question why these two different database instances are needed, because then it just adds more overhead managing these tables, right? Why are these two different database instances needed?
We can basically store into the same database, but to show it to the actual like so each DB instance like has a specific what you can say a task, right? So this accounts DB is only responsible for storing all the transaction related to all the users, right? And once you process those transactions and do some calculation and accumulate the result, you have to show it to some you have to put it in some different DB. You can choose a different table in the accounts DB itself, but like to show it to the high level, right, design, like we can we have
the overhead. I understand that you're trying to separate out the databases based on features, but now the accounts DB doesn't know who will manage that the user ID. Let's say the user ID with ID 1 is the same user with the user ID 1 in analytics.
Okay.
Who will do that constraint management?
Okay, that makes sense. So that constraint management will be difficult. Yeah, so we can keep in the same DB in the separate tables, or and we'll just don't worry about this separate DB.
Right.
Yeah.
So, I think that makes more sense to me.
Yeah. Okay, so we will store into the same DB and we'll get it. So in the actual interview, like will because I have seen in like many questions on the systems, and right, like each of this we have a certain number, different amounts of DB, and once the processing is done, it will keep into the separate DB, right? So that's why I went into that way.
I think it depends on the use case, right?
Yeah.
I think it depends what they're trying. I don't know which case you're referring to exactly.
Okay.
But yeah, there could be a case where, you know, if it is entirely separate, then you could keep it in a different database, right?
Okay.
But in this case, it's not, right? Because you would have to make sure that the type of data and, you know, the actual values in that data are same across both of those data sets.
Yeah.
So that's an issue here.
Yeah. Yeah. So the you were saying the bottlenecks we have to discuss, right?
Yeah.
So the bottleneck will be bottleneck happens when we have a large amount of user base, right? And everyone is trying to access the service. The bottleneck, one bottleneck will be like, what if the link service fails? It will not able to fetch the records, or like, is it should we assume that like this bank service API is always available?
Sure. Yeah. I mean, in reality, you would have to do error management, and technically, you should probably put,
because this is not in our hands, right?
Yeah.
Expecting the data records from the bank is not in our hands, so we can't do much on that side. But we so let's the link service, whenever the customer is trying to link, it throws an error. So
you will have to respond in a graceful manner.
Retry. Sorry.
You will have to respond in a graceful manner if the bank API returns an error, and you have to give informative, you know, solution to the user so that he can take some action.
So so this will not be the bottleneck from our side. The bottleneck will be the single DB instance. Will we have lots of transactions, right, from all the users. The single DB instance will fail, and if it fails, like, the analytical service will not be able to work. And because this analytical service also, like, the application servers, to get the accumulated data from this, like, analytical DB, right, and this analytical table, all the requests are handled by the single DB. That's why, like, one reason to separate the DB instances, right, because the analytical service continuously hitting the databases and getting the data to generate the new data, right, to accumulated data.
Right. But then there are other solutions for that, right? Because the having two different instances has a fundamental problem, right? It cannot be done, I think. Unless you're able to cleanly separate the data where there are no relationships between between the tables, which I don't think is possible in this case, at least.
In this case, it's not possible. But that is one way, like, to separate the data if there's no relation. And like, this is the bottleneck I see, where we have only one instances. We definitely need to shard it based on the some based on some parameter, right? And once we shard it, we also have to replicate the data, so that in this will be this instance will be always available, right? And we also have to add some load balancer in front of the database instance, because we sharded it, right?
Sure.
We have to add the load balancer instead of here, and all this request to this DB should go from this load balancer. So the sharding should be based on the user ID. If we shard the the database using user ID, that will be like each user, each shard will get the consistent like
So then that would be
record.
like, so that means the database will have millions of shards, right? If millions of users use this system.
Yeah, it not millions of shard, but okay. Millions of like each user will get a different shard in that way.
Right.
But oh yeah, the millions of sharding is not feasible. So we had to come up with a shard key. But if we shard based on user ID, and we can do like the consistent hashing,
So
right?
you're saying hashing, sure.
If
Yeah.
we do consistent hashing, then we don't need
Sure.
millions of shard. Like
Sure. Yeah.
it will have like based on the calculation. If we do the storage calculation, like we will decide like how many shards we require, and
Yeah.
let's say we have for like 5 years, or for 5 years we want to keep the data, and we have like 300 GB or something, right? Based on that,
Sure.
we'll decide how many shards are required, and those many shards will place in the will place for the consistent hashing, and all the user data will be sharded into those servers. And the load balancer is the responsible for like picking the shards based on the hash key.
Sure.
And this analytical service is the one, again, because this has to process the records for millions of users. So this will be not
Sure.
It will be the multiple servers running background and continuously getting the value from the DB and pushing into the new table.
Sure.
The application server will also be not a single server, it will be the multiple servers.
Sure.
So load balancer is required whenever there is a multiple services, like there is a multiple instance of any specific component, like this DB as well as this analytic service, as this between these two service. So the two load balancer makes sense, or if we have lots of linking service going to happen. I think the linking service, we also need to like do the multiple servers, because if one server is fail, then
I think that's fine. I think those are generally, as long as your system is linearly scalable, you can just throw more machines at each of these services, right?
Yeah, the load balancer is main and the sharding is main, right?
Yes.
Yeah.
But I think so the main bottleneck I would see where they would happen is as more users get added, the queries to the bank services increase dramatically, right? Let's say each person brings in like 5 of their bank accounts.
Yeah.
Right. And then so suddenly the queries to the banks increase dramatically.
Yeah.
So that's one place where we could see bottleneck. And the analytical service, does this need to query the database, or because anyway it's running it in the background as a cron job?
Yeah.
So why does it need to query the database? It doesn't need the real-time data, right, from the database. And anyway, it's running on a schedule. So it doesn't help if even if it gets the latest data, because only, let's say, it will run once a day or something like that. So how
Yeah.
would you solve that problem?
So it doesn't get the latest data, right? And
yeah, because it's running on a schedule, right? So
yeah,
so it won't get the latest data. So does it need to query the database?
so it doesn't get the latest data. And if user wants the latest data, right? In that case,
I think that might be fine, because anyway we cannot guarantee the latest data to all
yeah,
of our users, right? Because
yes,
that's just not a feasible feature
yeah,
for us. I'm just it's like a technical question I'm asking.
okay,
How
okay,
would you solve this technical problem? Not like a functional problem
okay,
for the user,
okay,
but a technical problem of avoiding so many queries to the database if it is just a cron job and not an application server that needs, you know,
yeah,
like a database that is up 24/7.
yeah. If we want the latest,
Yeah,
yeah,
I have to drop off now.
okay,
Yeah, good luck to you. All right, bye.
yeah, thanks.
Thank you for watching, and don't forget to visit systemdesign.us for more questions and solutions. Please subscribe to our YouTube channel and click that bell icon so that you do not miss any new updates.